Hello viewers, welcome back to the second question of today mathematics class for this upcoming WAEC examination. Okay, so in case guys you missed the first question and you wish to attend the first question, it's not only wish, it's very important to attend the first question because these are the likely questions you should be expecting this upcoming mathematics WAEC examination. Do not joke with this question. I said it in the previous class, do not joke with this question. So if you are a type of student that you are afraid of mathematics, that you find it difficult to understand mathematics, so this channel is meant for you and this page is meant for you. So let's see how you can solve this question. In the previous class we discussed about logarithm, and in this question here we discuss about set theorems. They are a very important topic you should not even joke with, though we still have close to 90 plus of questions to solve for this upcoming WAEC examination. And at least if you can attend to the next question, I can promise you you definitely have A in your exam. Yes, I can assure you, because this is how we used to do every single year, and lots of students share testimony on it. This is a VIP class, but I decided to make it free this year, so don't joke with it. And you also be the part of the student that will share testimony of A in their mathematics exam. So let's dive straight to the second question. If t is equal to prime number, okay, the set of t they are prime number, and set of m they are odd number, are subsets of the universal set. So when you have a symbol like this, it means what? Universal sets. Okay, so open bracket, that means s shows that 0 less than s less than 10, and s is an integer number. Okay, come on, you have to find the t complement intersect of what? M complements. Now, how do you solve this question? And is the first time I've said this question like this, or maybe I've said this question is not the first time? So how do you handle this question? This question, I said it is for set theorems, because we have about subset something set here, so you should know that is what it is set. It is under set theorems, and you cannot escape question under this topic. No matter how easy, you cannot escape it. If at all you are praying that you escape topic question like it, in this upcoming examination you cannot escape it. So that is why I said that this class is meant for you. You should attend this class. Okay, let's dive to the solution of it. So let me try to read the solution. So let me provide the sets t. So let's say that set t is equal to set of what? Or a prime number. So the first question you should ask yourself now, what's a prime number? Okay, in the easiest way from your primary school, let me just break it down to the understanding. What's a prime number? A prime number is a number that has two factors, 1 and itself. Okay, it means that the number that can divide that certain number, there should be 1 and that number itself. Okay, the first prime number is 2. 1 does not classify as a prime number, so the first prime number starts from 2. Now, after the 2, the next number that's a prime number is 3, because nothing can divide by 3, is only 1 and 3 itself. So the next one you have 5. Okay, 5 is also a prime number, because nothing can divide by 5, is 1 and 5 itself. And the next one we have after 5 we have 7. 7 is a prime number. After 7 we have 11. After 11 we have 30. So we have to stop at this 30 because our universal set is stopped at this 10. Okay, that should be the first thing you should do yourself, because I have to follow the step by step of this question. So let's stop at this 13. So let's go. That is the solution. That's are the elements. Those are the prime number that's fall between this 10. I get done. I'm supposed to stop at 7. Okay, you can start at 7, but let's just leave it as 13. Now let's go to the next one, that is m. So we have m. There's m, the set m, and they are the set of odd number. So you ask yourself question, what's an odd number? Odd number are a number that cannot be divided by what? By 2. So if you want to use number 2 to divide by a certain number, if you cannot divide they are called odd number. Right from primary school, odd number are a number that cannot be divisible by 2. The first odd number is 1, because 1 is odd number. You cannot divide 1 by 2. I get now. So the second one, 2 is not a whole number. We have 3. Okay, so the next one we have 5. Okay, because 2 cannot divide by 5. If you say 6, 2 can divide by 6. So 7 is the next odd number. We have 7. Okay, after 7, what's next again? We have 8. 2 can divide by 8, right? So the next one we have 9. Okay, so if you have another one again, that is 10, right? 10 is not an odd number because 2 can divide by 8. So the next one is 11. So let's start at this 11. Let's start at this 11 because the highest number we need here is 10. So let me tell you the reason why we need 10. Here we talk about the universal sets. The symbol like this, the symbol you see like this, I don't know how to do it very well. They are called universal sets. It means that all the number you have in this first element sets, the set T and set M, they should be under this universal set. That is what you call a subset. All of the elements you see here can be found in this or in between these universal set. Now the universal set interpret that S shows that 0 less than S less than equal to 10. How do you interpret these statements? 0 less than S less than equal to 10. How do you interpret this inequality? That is where students made a mistake. They find it difficult to interpret this kind of inequality. So this is the application of sets due to inequality, that leading to inequality. Let me say that inequality question that leads to what sets is still the part of it. It's application of set theorems. Now, how do you understand this? How do you interpret this? This one means that this S, they are the number that falls between what that is less than 10. Okay, what are the number less than 10? But it is what equal to this 10. So what are the number that is less than 10 and equal to 10? So you can first write 10, okay, because it is equal to the 10 and this is less than what? 10. So that is why I write 10. Assuming that it is not equal to 10 here, it's not equal to here, I don't have to write what 10. That are the number less than 10. What are the number that less than 10 that have 9? Okay, so because of this equal to, that is why the tail what is visible, it is appeared. So the next number that's less than 10, we have 9. Okay, after 9 we have 8 less than 10, and we have 7, we have 6. After 6 we have 5. After 5 we have 4. After 4 we have before 4, okay, let me say before 4 we have 3, and before 3 we have 2, and before 2 we have 1, and before 1 we have 0. Because here it is not equal to 0, it means that we should stop at 0, but we don't have equal to here, so it means that this 0 is not included. Okay, now they are just use this one as the stopping point. When this is 0, they are the number less than this one, this 10, but it's not equal to this 0. Assume that we have equal to here, so then it be 0, it be included in the range. So it means that the interpretation of this inequality is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because it is equal to, if they don't have equal to here, it will stop at 9. Because of this equal to, that is the reason why we stop at this 10. Assuming that we have equal to here, you will need to include 0 at this place. So it means that all the universal set, they are this. That's number from 1 to 10. So let me try to break it down here, and let me write it here. So our universal set now will be equal to, that is, so number of 1 or 2, okay, 3 or 4, 5, 6, okay, 7, 8, 9, 10. So these are the universal set now. Now they say that all this set T and set M, they are the subsets of this universal set. So that means that the number you can find in this T and the number you can find in this M, they must be they are the number you can find in this universal set. This is the meaning of the subset. It means that the number, they will be all the number you can find in this one universal set. So what are the number you can find in this universal set? They are 1 to 10. Okay, and here we have, when I interpret it, it is more than 10. You have 11 is more than 10. So you can rewrite this T as to be equal to, if you like to rewrite it, but let me write it to avoid mistake. So this T to be equal to, we have 2, we have 3, we have 5, we have 7. 11, we don't have 11 here. So let's stop at this 7 here. We don't have 11 here because it's a subset. This T must be the subset of this word, of this universal set. So the number you can find in this universal set alone, that will be the value for this, the element of this T. So the same thing goes to this M. They are the odd number, and we have write the odd number here, but here it is more than the highest number here is 10. Here we have 11 here. So let's mean that let's write only this one downward here. So that be equal to, that is 1 bracket 3, 5, 7, and 9. Okay, we stop at that 9. If it is right 11, we don't have 11 here in the universal set. Now the next thing to do here, you have to ask the question now, find the the t complements and m complements. What does it mean? What does it mean by complements? You have to say something like this: t raised to the power of 1. It means that t complement. What do I mean by t complement? It means that inverse of what? Of this t. It means that you subtract the element we have in this or t from the universal set. So the remaining element is to be the what? The t complement. Let me put it in this way. To find your t complement, it means that you subtract or you remove all the elements in t from the universal set. I think that's why it's better. Just remove all the elements in this t from this universal set. So after we remove it now, the remaining elements is to be the answer of what? Of t complement. So let's dive to it. So let's say it now. Here we have 2. If we move 2 here, we have the first number here is 1. So we don't have 1 here. So it means that 1 is the t complement. Okay. We have 2 here. This 2 we cancel 2 here. So 2 appears here. So this 2 here it will cancel. So you don't need to write this 2. Next one is 3. 3 cancel this 3 here because this one has 3. You have to count this 3. So you don't need to write 3 as the t complement. And here we have 4. This doesn't have 4. So 4 is a complement of t. And also we have 5 here, and here we have 5 here. So 5 is not a complement of t here. Here we have 6 here. There's no 6 here. So it means that this 6 is a complement of what? Of this t. And here we have 7. 7 is not a complement of t here. So what are the number again? We have 8, 9, 10 because they can't find it in this t. So it means that we have include that what? We have 8, 9, 10. I'm in the bracket now. So let's close it. So after we remove all the number we can find in this t from the universal, these are the number remainings. So if you say this 2 cancel this 2 here, 3 cancel this 2 here, 5 cancel 5 here, and 7 cancel 7 here. So what remaining 2, okay, remaining 4, and remaining 6, and 8, 9, 10. These are the t complements. The same thing goes to the m complements. M complement. So let's put it to m complement. So let's remove 1 from this space. So we have a 2, and here is not have 2. So if we remove 1, you have 2 here, and 3. Let's remove the 3 from this place. The next one here we have 4. So we don't have 4 here. So it means 4 is a m complement. And the same thing here, 5. Okay, we cancel 5 from this place. So this one also has 5. So you have 6 here. You don't have 6 here. So it means that we have 6 is the complement of m. You have 7 here. 7 cancel 7 here. Okay, we have 8 here. Here does not have 8, so 8 is the complement of m. You have 9 here, so we also have 9 here. So they cancel each other. Then we have 10 here. We don't have 10 here, so 10 is the complement of what? Of m. So if we move 1 and 3, 5, 7, 8 from this space, now it not remain what? 2. Okay, we have moved this one. You now remain 2, 4. Okay, 2, 4. We have 6. We have 8, and we have 10. That's remaining as what? As m complement. So we have get our t complement, and we have get our m complement. Now let's find the intercept. So you have t complement, intercept of what? Of m complement. Now this intercept means that the number of elements they have in common. So what are the number they have in common? Means that the common elements. So this t complement now, we have 1, 4, 6, 8, 9, 10, and our m complement, we have 2, 4, 6, 8, 10. So what are the number they have in common? What are the elements they have in common? So that is the answer. That is the meaning of this intercept. The one they have in common, the element they have in common, that is the word called this intercept, and that is the symbol for intercept. The one they have in common. Okay, I get now. Now, what are the number they have in common? We have 1 here, they don't have 1 here. So the first number here is 4, and there's a 4 here. So we have 4, come on. We have 6 here, we also have 6 here. So they have 6 in common. Okay, come on. And you have 8 here, we have 8 here. So they have 8 in common. We have a common. And you have 9 here. This one does not have 9 here. So it means that 9, they don't have 9 in common. We have 10 here, and this also have 10 here. So they have 10 in common. So the answer they have in common here is what? Is 4, 6, 8, 4, and 4, 6, 8, 10. These are the number, and these are the element they have in common. So therefore, the answer should be this. Our t complement intercept of m complement. The answer is 4, 6, 8, 10. So let's see to the answer, and let's get an option. So what will be the option? That should be option A. So the option A is the correct answer to this problem. I hope you guys enjoyed the class. I break it down, did I? Okay. The next question, that's question 3, we shall dive to it in this class. So don't forget to subscribe, like. If you're watching us for our Facebook, don't forget to subscribe and also follow us so people can benefit from it. Share with your friends, and let's dive straight to the next class, that is question 3. So guys, let's go.